Hello everybody, and welcome to the video that summarizes page 114 in the workbook. And what I'd like to do is to just make an observation that's going to help lead us into the substitution rule on the next page here. Okay, so as you look at the examples that we did on this page, they all kind of have the same flavor to them. They started by calculating a derivative of a function using the chain rule and using that calculation to come up with an integral. Okay, and the question I'd like to pose here is the following. Would it have been possible to do this integral in part B without having first done this derivative calculation above? Turns out that the answer is yes, using something called the substitution rule. Okay, so before we state it on the next page, I want to make an observation that might motivate it a little bit. Okay, so going back to this calculation at the top, the basic idea was that we gave the function x cubed the name u, and notice where the u appeared in our answer. We had a u there, and here we had a u prime. So we took the derivative of sine of u and got cosine of u times u prime. We could label those things similarly down here in our calculation of the antiderivative. We had a u here, a u prime there, and a u here. So we integrated cosine of u times u prime, and we got sine of u. What's kind of interesting about that calculation is that this u prime disappeared when we took that integral. Okay, and when we develop the substitution rule on the next page, we're going to discover that this pattern happens. It's very typical of how the substitution rule works.